Hi everyone, welcome to Fun with Flight. My name is Janet Akselrud and I'm an intern at the Kashmir World Foundation. I've just finished my first year at the Macaulay Honors College and I'm currently a physics and English double major. I'm really glad you're all here and I hope we're going to have a lot of fun learning about flight. So let's get started. First, let's ask the question, what animals do we know that fly? Imagine any animal that you've ever seen, heard about, read about. What animals do we know that fly? I think of a pigeon because there are lots of pigeons in New York City, but you might also think about a swan, an eagle. There are lots of birds. So now that you have one in mind, do you know how they fly? It's pretty amazing that birds can fly because humans can't. I mean, we fly in planes, but besides that, we haven't been able to fly by ourselves yet. So, how do they fly? Let's watch a video. If you ever need to pause or slow down, you can always replay part of the video or anything. Okay? So, here.
How do birds fly? Well, it mostly has to do with the shape of their wings and how they move them. When a bird flies, it flies through the air, and the air flows over and under the wing. If we look at a section of a bird's wing from the side, we see that it is big up front and then tapers off toward the back, kind of like an airplane wing. When talking about flying, this shape is called an airfoil. Now, the air flows around the wing like water in a river. If you've ever been on a river, you'll notice that it moves very slow at the wide parts, but speeds up really fast when the river narrows. This is because the same amount of water that was in the wide parts now has to move through a much smaller space at the narrow parts. And so the air is just like several rivers flowing side by side past the bird's wing. The shape of the wing, the airfoil, makes it so the river of the air that flows over the top of the wing gets squeezed and narrowed. And just like a river, this air has to speed up. And the river of air that flows under the wing actually widens and slows down a little. Now imagine you are traveling down this river of air and you have a cannon on your boat. The airfoil is an island, and you are trying to shoot it with your cannon. But you have to reload the cannon every time you fire, so you can only shoot it once every few minutes. If you are going really fast down the river, you will only have time to shoot a few cannonballs at the island. But if you go down the wider part of the river at a much slower pace, you will be able to hit the island with more cannonballs. This is kind of what happens with a bird's wing, but instead of cannonballs, it's the air that's landing on the wing. Because the air on top is pushing less on the wing than the air on the bottom, the wing gets moved upward. This upward push is called lift, and it's the main reason birds are able to fly. But there are other tricks birds use too. To get more air to pass over their wings, birds will flap them, especially when taking off. When they do, they rotate their wings forward and down and then lift them back up to start over again. Rotating the wing forward causes the lift from the air to push the bird not only in an upward direction, but forward as well. This forward push is called thrust. As you can imagine, all this flapping takes a lot of energy, and so birds have large lungs to help them breathe and strong muscles to move their wings. Not only that, but their body is shaped to cut through the air efficiently, and their bones are hollow, which makes them very lightweight to begin with. So a bird relies on many tools to get through the air, not just its wings. As for people, we are heavy and can't produce the energy needed to fly by ourselves, so we use aircraft to get through the air. And even though we use machines to get off the ground, it's still fun to imagine that we can fly like the birds. How do birds fly? Well, at most
Great, now that we know how birds fly, let's look at another video because there are many different types of birds, whether it's an owl or a pigeon or an eagle. They all fly in different ways, and there's a reason for that as well. So here's another video.
Long soaring wings. The easiest wing to describe is the long soaring wing. These wings are long. The albatross has a wingspan up to 11 feet. But you'll notice their wings are also very thin, and they are very streamlined. These are on birds that stay up in the air for days in a row, usually over the ocean, so these birds rely on efficient wings that catch as much air as possible without lots of drag or turbulence slowing them down. Albatross are able to stay up in the air so long because they get up to 90% of the energy required for flying from the air itself. They can catch rising air currents or move to a different altitude where the wind is blowing in the right direction. An airplane that borrows this design is the glider. This is great for efficient flight, but there is a cost. Albatross take a while to take off from the ground or to land because their streamlined wings don't catch enough air to stop or turn quickly. Delta wings. Now let's take a streamlined soaring wing and make it short. You want to have short wings to flap really fast so we can fly really fast. That way we can chase prey. You know what's a way to go even faster? You can fly up high, then dive down. So you want your wings to fold in a triangle like a fighter jet so you can steer just a little bit, but mostly your wings get out of the way so you can go really fast. Then you come screaming in like a peregrine falcon after its prey, going 240 miles an hour and catch it, or like a swift that is literally named for being fast and does these complex aerial maneuvers to catch bugs. And yeah, delta wings are about going fast. Slotted wings. These wings are almost the opposite of what we've been talking about so far. They are big fat wings that have feathers sticking out all over the place, especially on the tips where you'll notice deep slots between each feather. The broad wings and slots are for catching lots of air. These wings can be used to soar on rising warm air currents, but they do have one amazing use. They let you pick up something heavy and carry it into the air. So an eagle can swoop down and grab a prey animal, then use its slotted wings to get up and away from the ground with its meal. Slotted wings are also great for taking off from the ground quickly. Elliptical wings. These wings are a compromise between the other types. They have extended feathers to help catch air so they can turn quickly as they fly through a forest. The feathers also allow them to take off quickly and efficiently as they explore different trees looking for food. On the other hand, their wings are narrower and shorter than a slotted wing bird, so they can fly fast for a short amount of time. They can't lift as much as a slotted wing, and they can't fly as fast as a delta wing, but they can do a little of both as needed. Now that we've learned these 4 wing types, let's see if you can guess how this paper airplane will fly. Look at its wings and see if you can figure it out. Is it like a long soaring wing? Is it like a delta wing, a slotted wing, or an elliptical wing? This airplane looks like a delta wing. The wings are tucked in to go fast, and it does. Now you know a new trick. You can look at a bird and guess how it flies. You don't
Well, we're going to make some of our own paper planes today. And they're going to look like this. We're going to make the basic paper plane, then we're going to make the basic dart, and then we're going to make the tailspin. Those are very different, so we're going to have to experiment with how they fly. Now, first, let's talk about what you think will happen, kind of like a prediction. If you have a piece of paper, you can write down your predictions. If you want, you can just think about your answer as I ask the questions. So first question, which plane do you think will be the fastest? We have number 1 is the basic, number 2 is the basic dart, and number 3 is the tailspin. I think, I'm not sure. Maybe it's going to be the basic, but maybe it's going to be the basic dart. They both look pretty, they both look like they could be really fast. Okay, next question. Which plane do you think will be the farthest? And I mean, which one will fly the longest distance? So if we had 3 hands and we're able to throw all 3 planes at the same time, which one would land the furthest away from you? I think maybe it's a tailspin, maybe not. Maybe. We'll have to experiment, but a hypothesis, it's interesting to know what you think. Next question. Which plane do you think will stay the longest in the air? Once again, same choices, either 1, 2, or 3. I think it might be the basic one. it looks like it can stay in the air for a while. Okay, now that we have some predictions, let's make some paper airplanes. So make sure you have your pieces of paper. You need 3 pieces of copy paper like this. And I'm going to be showing videos. I took them from foldandfly.com. They're very great. They have so many different paper airplanes. You can even make one that looks like a sea turtle. They're really cool. So I'm just gonna play the videos. Need to if you need some more time to make your paper airplane, you can always pause and or go back to look it over. So here we go.
Today we're going to show you how to create the most basic paper airplane. To begin, fold the paper in half vertically and then open back up. Take one corner and fold it into the center crease and then repeat with the other side. Now fold the plane in half. Fold the first wing down so that it reaches the bottom of the plane. And finally, repeat with the other wing. And that's how you create the basic plane.
That was plane number 1, and I have it right over here. This is what the basic plane looks like. In case you got a little bit lost for folding the wings, when you have a shape that looks like this, after we have folded the side, the top into the triangle, and we have folded the plane, you are taking this side over here and you are making sure to fold it to meet this side right over here, just like this. And that's how we make the wing. This is important because this is going to be very similar in the other planes as well. And the same thing on the other side. We're going to take this flat line over here and match it to over here. So we have our first plane. And now it's time, so this is the basic, and now it's time for the second one, basic dart.
Today I'm going to show you how to create this iconic paper plane called the basic dart. To begin, fold the paper in half vertically and then reopen. Today I'm going to show you how to create this iconic paper plane vertically and then reopen. Take both corners and fold them into the center crease. Now repeat the last step with the outer corners. Now fold the plane in half. With a ruler, fold down the first wing starting at the peak. And finally, fold down the second wing. And this is what the basic dart should look like.
So here I have a basic dart. Once again, don't worry if the wings are not parallel right away, because when folding them, all you need is to make sure that this line matches up to the bottom of your plane. So I hope that you have your plane now. You don't need a ruler. If you don't have a ruler, that's perfectly okay. You can just fold the plane wings down by yourself. So now we have 2 paper planes. Are you ready to make the third one? Let's get started.
Today I'm going to show you how to create the tailspin plane. Fold the sheet of paper in half. Open it back up and fold both upper corners to the center like this. Repeat the last step with these two upper edges. Next, fold down the top peak. Now, fold the plane in half. Fold out one wing and then repeat with the other side. Finally, fold up the end of one wing and then repeat in the opposite direction on the other side. This is what the tailspin should look like.
All right, I have my tailspin right over here, one wing facing down and one wing facing up. So I hope you have yours too, because now we're going to experiment with them. I made a data sheet just for this occasion. So if you are interested, I will show you what it looks like. It looks like this. And if you have the chance to print it out, of course, feel free to do so. If not, you can always draw it on your own piece of paper and just have some fun. You can pause the video, take some time to throw each of these paper planes. I will show you an example in a second of how each one of them flies, just in case one of them didn't work out or something, just to show you what I have done. And I hope you just enjoy it. It's fun to experiment. Keep doing as many trials as you want so that we can really answer the questions of which plane flies the fastest, which plane flies maybe the slowest, which plane stays longest in the air. All of them are going to be answered pretty soon. Okay, so if you need to look at the data sheet, just go back and pause the video. But here is a look at how these planes fly. Let's start with plane number 1, which we have over here is called the basic. So I'm going to throw it, and hopefully you will be able to see what happens. That did not go very far at all. Yeah, the basic plane doesn't seem to go very far or fly straight at all. But that's okay. It's all part of the experiment to see. Now I'm going to throw the basic dart, which is the second one. One more time. This one certainly flies a lot faster from what I can see, and a lot further than the first plane. So now let's throw the third one, the spin plane, tailspin. I don't know if it will be caught on video, but this plane spins when it flies. That's the very interesting part. That's why we have to bend the two wings in the opposite direction. One more time. Now, if you would like, you can always throw 2 planes at a time so that they can race to see which one's faster. And then whoever wins, make sure they challenge the 3rd plane so that you can really find out which plane is the fastest. Now, I'm going to move on to the data collection and our results. So if you need some more time to keep throwing the planes to have more trials, feel free to pause the video, and then when you're ready, we'll move on. Okay, so in order to compare our data, I have a little questionnaire. And this is what it looks like. Let's see. There are a few questions so that you can fill in the data that you collected. For example, which plane was the fastest in your first trial, in your second trial, in your third trial? Which one was the slowest? Which one flew the furthest distance? Which one flew the shortest distance? Which one stayed in the air the longest, and which one stayed in the air the briefest? These are the questions. Now, if you do have this link, feel free to fill it out so that you'll be able to look at the graphs of everyone who has filled it out before you. But since you might not have that link, I will show you the graphs that we have from data taken during the live version of this webinar. So let's begin. Which plane flew the fastest? From these graphs, it looks like plane number 2, the basic, is the winner. Yay! Congratulations to the basic plane. We do have some data that says plane number 3 seemed to fly the fastest in a few trials that people have taken, but most of the data points to plane number 2. Let's see, which one flew the slowest? Oh wow, it looks like it was the basic plane, plane number 1. Yeah, I thought it was going to be the fastest at first, but it turned out to be the slowest. That's all right. I'm learning. Now, let's see. Which plane flew the farthest distance? Can we really tell? From this graph, it looks like there were 3 out of 6 responses from the first trial. 3 of them said that plane number 3 flew the fastest, the furthest, I mean. And then 2 responses say plane number 2 flew the furthest, and only 1 response is plane number 3. We have a very similar distribution in trial 2 and a completely different one in trial 3. We have 3 answers for plane number 2, 2 answers for plane number 1. From this graph, there's really no way to tell which plane actually flew the furthest distance. So for this, we would need a lot more trials, maybe more people, or just if you want to find the answer yourself, you can keep running more trials until there becomes a clear pattern. So let's move on to the next question. Which plane flew the shortest distance? That seems to be pretty clear. Plane number 1. And from when I remember throwing the planes, it is definitely very clear that it was plane number 1 because it didn't even move in a straight line. Sometimes my plane number 1 just fell on the ground. Next question. Which plane stayed in the air the longest? From here, it also looks like we can't really tell because even though plane number 3 has the most votes, it has 3 votes, 3 votes, 4 votes. So that is almost the majority of the observations taken. But there's still a lot of votes for plane number 2, and plane number 1 isn't excluded. There's a good 2 votes for that. And since we've only have 3 trials and so far only 6 responses, this also isn't very accurate to determine an answer, which is all okay. It just means there's more room for experimentation. And another question, which plane stayed in the air the briefest? From this one, it looks like it is plane 1 because there were quite a lot of answers for plane 1, but plane number 3 seems to come in a close second because there are quite a few answers for that one as well. Plane number 1, I'm sorry, plane number 3 over here has a few answers, and plane number 2 only has one response, so we can probably assume that's not the answer. But just to be sure, we definitely need to experiment a few more times to find out. So I hope that you had some fun and that you will go home and experiment even more with all of these. So, okay. Now that we know those answers to these questions over here, some of them we do need to experiment some more. That's all right. Now the last question left is, which plane was your favorite? It's whichever. I really like the one that spins because it's very interesting. But many people like number 2, which is the basic dart, because it flies really fast. If you want to make more paper planes, you can always go to the website, Google it. It's really fun. There's even one version of the basic dart where you get to make a little cut over here in the paper plane. So then you can place a rubber band and it'll almost be like a slingshot. And the plane that originally seemed to go the fastest, maybe the furthest even, now it can go even faster and even further. So yeah, it's a lot of fun. Thank you for joining me today. I would ask you if you have any questions. You can't really ask me right now, but you can always email me. My email is janet@thecashmereworldfoundation.org. So if you have any questions, feel free to reach out. And that is the end of our webinar today. So goodbye. Thank you. I hope you had fun.